All right, welcome to Whiteboarding. So this is less of a lesson, a little bit more of a demo, and we can do some Q&A and stuff also. So question was like, what does whiteboarding look like? So we have an example question here. This one's super common. It would not be unreasonable for you to get asked this specific question in an interview. Write a function to get the first n Fibonacci numbers. So let's go through our 4 steps on this and just kind of outline what the approach is going to be. So I'm asking, what's step 1?
Repeat the question.
Repeat the question and clarify the question. So what are some clarifying things that I might want to ask about this?
What n is them?
Sure.
How many numbers they actually want?
So like I'm thinking things like that. What bounds on n? So might I get given a negative number? How high a number could I conceivably be given? 1 million, 10 million, so something like that. I want to figure out what I'm kind of working with. I might also ask, I would not recommend you asking this, but I would ask this. Any constraints on complexity? This is the big O stuff. Do I have any constraints for CPU or memory or both? So knowing that whatever I write will eventually have to be like that big O or better. Other clarifying questions I might ask. Function. Particular language. I got asked this. Yeah.
I got a question as far as like, what if, for instance, you haven't memorized like the Fibonacci numbers or something like that?
That was going to actually be my next one. Like, even if you have, like, making sure that your understanding is shared, that's good. So, like, define a Fibonacci number. So, also, while you're doing this, that's also buying you time to start, like, turning some wheels in your head, just FYI. Cool. So I'd probably move on to the second step at this point, which is
Input-output table?
Input-output table. So, like, we'll do this live, but give me some examples of things that would be good things to have in this function. What are some good inputs to check?
Like a 1.
Okay, love it. So I probably want to check 1. What else?
Like 5, or just like more than like the base?
More than 1.
Yeah.
So I'd say 3. We'll get an idea of whether or not this works if we have 3. And then a recommendation, and like this is also a little bit beyond where we get to in the program with testing or TDD or anything like that. But there's an idea of, I'm spacing on the vocab word for it. It's not negative case. It's not base case. It is the like discarded case. Shit, I'm spacing on it. But the nothing. What does the nothing return? And so if I give it 0, what should I see back? If I'm writing a function that sums 2 numbers, if I give it 0 and 0, I should get 0 back. Degenerate case, that's what it's called. So you generally want to start with the degenerate case because it's the easiest one to do. And there's also like all kinds of goofy errors that you can catch when you're testing for degenerate cases. Cool. So that's the I/O that I want to use. And then as I work the problem on this, step 3, go with a naive solution first. This is probably the biggest mistake I see people who are new to whiteboarding make, is they try to get clever with this shit like right away. Like work with whatever you can comfortably do, which is probably going to be like lots of manual repetition, whatever, it's fine. Get it working and then try to make it better, which is probably part of this step. So we want to refactor in here. And what else do we want to do in step 4? Test it. Probably do that first, actually. So we want to test with our IO table. All right. Questions about the approach on something like this? Yeah.
If you don't know what what if they ask a question where like you don't know something basic, like what a Fibonacci?
Sure. So I'd ask them to define it. They might go, okay, cool, next question. Totally fine. But it might be a like, oh, cool, I'm so glad you asked that because we made it up. And we want to see if you just assumed that you knew it. Or like this could absolutely happen. They might be fucking wrong. And so you might do an actual Fibonacci sequence and they don't know that like 1 happens twice or something like that. Because like when you do story sizing with Fibonacci sequence, it's 1, 2, 3, 5. And so maybe they fucking forgot that there's 2 1s in there. Gives you an opportunity to correct them. So, cool. But yeah, otherwise, like, let's say you didn't know what a Fibonacci sequence was, like at all. And you go, huh, interesting. So it works like that, that. Okay. And then you can actually write the function. That's like double impressive points. It's like, holy shit, you like figured out an algorithm and you weren't even already familiar with the base concept. So it's not necessarily a bad thing. It's also an opportunity to flex a little bit. Cool, what else? One more thing I'd have you keep in mind about whiteboarding is that no competent interviewer does it. Like, this is a terrible interviewing technique. It makes everybody nervous, and so you're not actually seeing all that accurate representation of whoever you're interviewing. Also, as we've discussed many times, this is a party trick. This doesn't have anything to do with like programming. It's a thing that you can practice and get better at, completely separate of like whether or not you can program your way out of a paper bag. So if somebody's actually like a good manager, good engineers, like they don't interview this way. So if that helps you to keep that in mind, sort of like an interviewer has no clothes kind of thing, like use that. Yeah.
Do you usually know going into it whether they'll be whiteboarding in it or not?
You can ask. Like, it's pretty common to ask. Like, just a heads up, is there going to be any whiteboarding in this? Is there anything, or like you could also phrase it as, is there anything special I could prepare for the interview? And a lot of times they'll tell you. But also if they like surprise you with that, that's another like, all right, well, that's a red check mark against them in your head. Cool, what else? Every year, like fewer and fewer companies are doing this, but it's not zero, and it's probably I'd say a quarter to a third of companies out there are still doing whiteboarding interviews. So still valuable skill to have. And if we take like the negative piece of it out, this is a great way to communicate with your teammates. And it feels very different because there's no like stress or pressure, but just thinking out loud in front of a whiteboard, like that's how I generally work with people. So a lot of these skills will transfer to that. Cool, let's get started. Who's going to be my my proctor? Who's running this question?
I'm running the question.
All right, cool. All right, Toby, what are we doing?
You will write a function to get the first in Fibonacci numbers.
Cool. I got any like kind of boundaries on n? Like, can I get a negative number? Is 0 valid?
It will not be negative or 0.
Okay.
All positive integers are.
Okay, only positive integers. And so while they're saying that, I'm going to write that down. Only positive integers. Cool. What's the highest number like I would need to test for?
100.
Okay. So everything is less than 100. Cool. Are there any constraints on complexity that this needs to run in?
No.
Okay. Cool. So no complexity constraints.
Can I add a CPU constraint?
Sure.
I don't know. Yeah, there's going to be CPU constraint something. I don't know what that means. But.
Okay. So I'm going to optimize for CPU.
Yeah.
Okay. And then any particular language you'd like me to do this in?
JavaScript.
Okay.
Go.
Go. I feel like I wouldn't be going.
And then just so we're both on like the same page, like what is a Fibonacci sequence?
Let's see what it defines it as. Pretty sure it's 0, 1, 1, 2, 3, 5, 8, 13, 21, 34.
All right, hang on. So I got 0, 1, 1.
2, 3, 5, 8, etc., etc.
Okay, and then 13
So it's
onward.
the number plus the previous number.
Okay, cool. So, all right, so just to make sure that I understand, if you give me a 1, the first positive integer, pause. So this is so like we talked about degenerate cases, this isn't exactly a degenerate case, but it is a boundary. So this is like the very beginning of the Fibonacci sequence. So testing something at the boundary, always a good plan. All right, so if I put in 1, I should get 0. Is that correct?
Correct.
All right, and if I give you 2, I should get 0 and 1. These are arrays, presumably?
Yes.
All right, so that should probably be an array also. And if I do 3, I should get 0, 1, and 1.
Correct.
Cool. Any other cases I should test for?
No, looks good.
Okay, cool.
Maybe you should test for 4.
Okay.
Would it matter?
Well, let's see. If you want 4, I'll give you 4.
Cool.
That's just the kind of care and effort I put into this, Toby. So 0, 1, 1, 2. All right, so there's my IO table. So I'm writing gerbil script here, and before I optimize the CPU, I'm just to see if I can get this to work. So I'm going to say function get Fibo. Is it 2 B's? It's 1 B. A Fibonacci. Don't do racist impressions in your review. All right, so it's going to take in a count. All right, so timeout. This is a great opportunity to show that you know how to name shit. If you make this get fib num and it takes in n, like you already failed my interview. Like name shit descriptively. Shut up. What is happening? Cool. So it's going to take in a count and it's going to return the Fibonacci numbers. And I'm going to run a space, so I'm going to start this over again. So I'm trying to sandwich code here so I understand, and timeout. The thing I'm doing now isn't for you. This is what you do in the interview. You're like explaining your thought process the entire time that you're working. Action. So I'm trying to sandwich code this so I get what all of, I kind of know how it ends and I know how it starts, and then I just got to like kind of figure out the middle. So say Fibonacci number, and then and then I'll say Fibonacci numbers is an empty array. So if I just call this function right now, I know I'll get back an empty array. So based on this pattern, there's some kind of special cases that I noticed with this. After these first two, this works fine. But these first two kind of get seeded, right? So, because if I don't have those, there's no way I can really derive the rest of it. And so like these are kind of like seed values. So those feel like they have to be special cases to me. So since they're special cases, I feel like I should kind of account for them right after this. So maybe it's something like maybe I can, So what I'm thinking right now is like I wanted to initialize Fibonacci number maybe with 0 and 1 in it. However, problem is if the count is 1, it gives me back both of those, and I only want one of them. So that doesn't quite work. So I do need to like push them in. I don't love this, but it's a place to start. So I'll say like if count is 1, then Fibonacci numbers is I'll push it in. Say push 0. And then else if count is 2, then Fibonacci, I don't want to push twice. Okay, so here's like a legit thing you can do, timeout. I can't remember if you can push more than one number in JavaScript. Some languages you can, some languages you can't. So let's say I'm working in a particular language. I can't remember this. So action. I can't remember if arrays in JavaScript allow you to push more than one thing in. Do you mind if I look it up?
Yes.
You do mind that I look it up?
No, you can look it up.
Okay. All right, so I'm going to look for array push JavaScript. Head over to the MDN docs, and it says adds 1 or more elements. And it looks like they're comma separated. Awesome. So I'll say Fibonacci numbers dot push 0, 1. So right now, without doing anything else, I think I passed these first 2 test cases. So if I pass in 1, then that initializes to an empty array. If count equals 1, and it does, then I'm pushing in 0, skips that case, and returns that. So I get an array with, so Fibonacci numbers at that point becomes an array with 0 in it. That gets returned, and that's exactly what I'm supposed to get back. If I give it 2, then, all right, initializes to this. It doesn't pass this condition. It does match this condition, and so I push 0 and 1 into that. That ends up getting returned. All right, cool. So first two test cases are matched. Okay, next thing that I need to do is figure out some way to push in the sum of the last two. So I ran out of space, so what I'm going to do is just kind of like zoom in on that. All right, so take the two most recent, and so I'll put this like maybe in an else. Otherwise, I know it's oh, this is actually kind of interesting. So the first thing that I would do in this else block is push these first two in. So I'm going to do a little bit of refactoring right now and say that everything probably starts that way. So we don't need to explicitly check for 2. I'll make it a little smaller. So we'll say that's just a regular else. And then, so now I still need another condition though, because I only want it to keep going if the thing was more than 2. So I'm going to give a condition here, or if count is more than 2, then do whatever I'm about to describe in here. Okay, so I know that the count is more than 2, so I have these two things there. So my thought process is that I need to keep combining the last two numbers until I want to say the length, I want to spot check that to make sure I don't have an off by 1 error, until the length matches the count. That sounds like a good way to do it. All right, so do these match? Yeah, so 1, length of 1, 2, length of 2, all the way down. So I want to keep combining the last two until the length matches the count. I'm going to start with a while loop for this. So we could say something like while, was it Fibonacci numbers? Dot length is less than count. Let me see if it'd be less than or equal to. So I want to keep, well, I'll do it at the end. It's an easy thing to fix later. Okay, so while I haven't done this, then I want to take the current length and set it equal to Fibonacci numbers dot length. So in my case of 3, that should be, my initial case, that's 2. And then I want to take last number is Fibonacci numbers at current length minus 1. And then I'll maybe say that's a const. And then I'll also have a next to last number is Fibonacci numbers at current length minus 2. And then I can say Fibonacci numbers dot push last number plus next to last number. And so I want to make sure that whatever's happening in here can terminate. So is the length always changing? Because count doesn't change. So it starts at 2, and I'm pushing something into it, which makes it 3. And so it keeps going up. So let's take that 3 for an example. So it starts at 2. That's 2, that's 3. Current length is 2. Last number is originally 1. Next to last number, current length minus 2. So that would be at index 0, which was 0. And so I'm pushing 1 plus 0, so I'm pushing 1 into it. So now the length is 3, so I go back up here. Is 3 less than 3? No, it's not. And so that, which was 0 and 1, should now be 0, 1, and 1, which is exactly what I should get with that. So last one, make sure that all this works the way I imagine it does. Get rid of some of these. I say, all right, I'm passing in 4. I initialize an empty array. If the count is 1, well, it's not. So I'm pushing in 0 and 1 to that. If the count is greater than 2, well, by Jove, it is. So I go over here. Well, Fibonacci numbers.length, which is currently 2, is less than count, which is 4. Length is 2. The current length, which is 2 minus 1, is 1. So Fibonacci numbers at index 1 is 1. Next to last number is current length, which is 2 minus 2, so that's 0. And then I'm pushing in 0 plus 1, so that becomes 1. And now I have 0, 1, and 1. So test this condition. Is Fibonacci numbers.length, which is now 3, less than 4? Why, yes, it is. So current length becomes 3. Last number, Fibonacci numbers, current length, 3 minus 1. So now that's 2. and the Fibonacci number at index 2 is 1. So I go, all right, that's 1. The next to last number is current length, which is 3 minus 2, so that becomes 1. Fibonacci numbers at index 1 is 1. So I'm pushing in the combination of those, which should be 2. So now this is 0, 1, 1, 2. Does the test again. The length is now 4. 4 is not less than 4. So we go back over here and we return this array, which so happens to be that. So that's my naive solution for this. I was supposed to optimize for CPU. So something that I was considering with this is you can also do this recursively. So you make a function that calls itself to do this, which that actually might be better on this, because if I'm optimizing for CPU, the downside of that is it saves tons of CPU cycles at the cost of your memory getting enormous, because it has to keep track. Actually, I'm saying that, and now I'm not kind of believing it. So let me do a little quick pros and cons here. So if I call my solution the procedural way to do it, and I compare that with the recursive way to do it, so a recursive solution, with any recursive solution, one of the things you have to worry about is the call stack. So if this really was big, if 100 is the biggest number I'm doing, not a problem. But if this does need to scale up to 1 million, 10 million, 10 billion, your call stack's going to blow immediately. Especially in JavaScript, because JS has no tail call recursion, which is how you get around with that. You can trampoline, but you're starting to get into some pretty gnarly, hacky solutions at that point. My procedural solution, on the other hand, is, let's see. It can't be memoized. So the cool thing about the recursive one is, let's say I do 4, and then I do 10, and then I do 20. I'm calculating every part of that every single time. With the recursive solution, you can memoize that, so you just keep all the ones that you've had before, because they're the outputs of functions, and you can save the outputs of functions. So you can say can memoize. And my procedural one, I can't. However, it's also completely realistic that I'm not getting progressively more Fibonacci numbers, so maybe the procedural version works just fine. And then as far as CPU, I think they're probably both equivalent. There's the same amount of calculations being done in either one, but memory blows up if we do the recursive one, and we also might break the call stack. So I was asked to write a function to get the first n Fibonacci numbers. I gave you 4 test cases for that. All 4 of them pass. Those are some considerations that I would make in refactoring it. Cool. That's like kind of whiteboarding by the numbers. I was like, yeah, that was it. What questions do you have? Stacy.
How much do you care about being particular about consts and lefts and when you're gonna screw that up? Because for me, I don't know. It's hard for me if I'm juggling too many things in my head to be like, oh, this is wrong. Oh, I gotta go fix this. Oh, I gotta you kind of blow over stuff just to get it working and then kind of look back on stuff like that? Like, I don't know.
Great question. So the reason I did the consts and stuff is because I asked Toby if he wanted it in a language, and he said JavaScript. So do your best to write syntactically accurate JavaScript. However, like, there's some capitalization, some scribbly kind of shit that I was doing. Like, nobody actually cares that much. And also, most of the time, you'll get something like pseudocode. And the pseudocode for this looks similar, but not at all the same. So pseudocode for this first part of it would probably look more like this. Function get Fibonacci number. You can draw like pictures and shit. Takes in a count. And in a pseudocoding, you generally just indicate hierarchy with indentation. So I would say you can either do equals, but some, like in official pseudocode, I don't even think you do that. I think it's like set Fibonacci numbers to zero, and then if count is 1, push 0 into Fibonacci numbers, else push 0 and 1 into Fibonacci numbers. Like, that's the pseudocode way to do it. Still structured logic, no syntax.
And what are they looking for? Do you ask? Do you want pseudocode or real code?
So like if you say, like, is there a particular language you'd like me to do this in? Like, the pseudocode's fine. Or whatever you're comfortable with. And so if you would be more comfortable with something like this, by all means do it. But if you do choose to write it in something like JavaScript, make sure that your syntax is clean, because you are making it fair game to beat you up about that. More questions? Yeah.
Have anyone, like, in an interview, have they ever put like a time limit, like you've only got so many hours in order to do that? Like,
Yeah.
how exactly do you handle that, I guess?
So if somebody does that, they're probably trying to see how you prioritize time. And so what you want to show is that, like, all right, I can get a naive solution working quickly. And then with your hopefully extra time, you start working on how you would improve it. And let's say you do run out of time, you can't get it solved. You go, okay, so I ran out of time, but the next things that I was going to do were this and this and this. Good questions. What else? Yeah.
You get a question that like is pretty simple, like you feel like you could do it like relatively quick, would you still, like you were taking a lot of time going through all the steps, like, explaining like pretty basic stuff.
Oh yeah.
Yeah.
Well, like, the party trick on this is, can you think like a computer? And so you want to show that you can think like a computer. And like a lot of those like simple questions, you'll mess up shit like, is it less than or equal to? It's little shit like that. What is it, index 0 or is it index 1 that I'm looking for? Little shit like that. -1 or -2 for those. That's the easiest stuff to trip up over. And if you're talking out loud like a computer, you'll catch those. And if you're not, you won't.
So what happens when it's like out of your brain? Like you just don't get the question and you don't know how to solve it. Like,
Sure.
you just kind of like go for it still.
Awesome. Let's do an example of that. I want to make sure we've answered any questions people want for that. But like, Call that the impossible question. More questions about my approach to solving that Fibonacci one.
I have a question, not really in regards to this, but do you have any like good recommendations for like practice sites we can go to other than Whiteboarding?
Pramp is kind of the go-to. That one, like, don't get over intimidated by it. It's really easy to. So Pramp is like you get paired with somebody and you interview each other. And a lot of them are like Stanford CS grads, and the questions are very Stanford CS grad-y. And I don't know. So like if you get those kinds of things, it's not an example like, oh my God, I knew all the interviews were like this, and I'll never be able to pass any of these. It's like a particular kind of thing. But Pramp is another popular one.
Do you like Code Wars?
I like Code Wars. I like it better than the other one. Code Wars is the one with like the 0 through 9
Like
Q or whatever.
What they call it.
Yeah. There's another one that's like equally popular. That's like you. Yeah, is HackerRank the one where you battle people? I fucking.
That's Code Wars.
Code Wars. That's Code Wars?
Well, you don't actually battle people, but like everyone puts in their solution, and then you're able to see other.
No,
people's
that one I
solutions.
like. That one's really cool, and I think that looking at those other solutions,
Helps factor.
yeah, like there's a lot you can learn from those. Especially like the shortest ones will always be some clever language trick, like a bitwise operator or something like that. So it's a good way to learn some of those kinds of things. There's one of those that like you battle somebody else in real time. Like fuck that. That shit is dumb. But yeah, that one I think is pretty cool. Good practice.
It's Pramp, P-R-A-M-P.
Mm-hmm. Other questions about how we did this? Yeah.
So in your solution where you got the last number and
Mhm.
the previous number, wouldn't just, it doesn't like -1 just give you the last number of any?
Not in JavaScript.
Not in that. Is that?
It doesn't Ruby.
Oh, never mind.
It doesn't like half the languages,
Yeah.
which like no grown-up memorizes all that shit. So that's why I looked that up, because there's lots of languages, including I think Ruby, where you can't push more than one thing at a time. So
That's weird. 'Cause I did that in JavaScript yesterday.
what else? Cool. Let's do one that I can't answer. Find one. Hard ass interview question.
What's the meaning of life? I found out I had 42 the other day, and it was a cool answer. It was like a computer answer.
Really? Like this quantum physics one?
No, it's just like it's a computer science.
You can find
It's
that
like
and send
how
that to me. That'd be tight.
computers think, and that's why it's 42. It has to do with star. It's like star. You know how star is everything in coding? Like if you want everything, you put star, and like there's something about what star is written as in like the basic compute, like in basic computers. It's 42.
All right, so I'm looking at this data science interviewing questions thing. You get asked some of these. Tell me about an original algorithm you've created. I've never created an original algorithm. I imagine most of you haven't either. So somebody asks you something like that. I go, I haven't made one. Not how you answer that. Ask me, Toby.
Have you made your own
No,
algorithm?
use the language they have here.
Are you hovering over it?
Tell me about an original algorithm you've created.
Tell me about an original algorithm you've created.
Well, I actually don't do a ton of algorithms work, and so I've never created an original algorithm. However, I always thought it'd be kind of cool if you had one that like, so like I work with students a lot. I'd love to see how connected they are to other students that have graduated from the program. Never done something like that, but I always thought it would be cool. Still did not talk about an original algorithm I created, but I didn't go, "Yeah." Just talk. let's see. Explain how Mapreduce works as simply as possible. I kind of know this one, but I'll pretend like I don't. So let's see, Adam, ask me that question.
Explain how Mapreduce works.
So I actually haven't used Mapreduce before. However, like I can make some guesses about it. So the word map is in there, and a map is when you transform a set of things, and a reduce is when you combine a bunch of things. So I'm guessing there is some kind of transformation that's happening on like a collection of things, and then they all get summarized somehow. That'd be my guess for how Mapreduce works. Same thing, admit it up front, I don't know what that is, but I used my big brain to take two words that I did know and give it a shot. And in fact, I'm pretty sure that's close to right. Let's take a look. Mapreduce programs consist of a map procedure, which performs filtering and sorting, and a reduce method, which performs a summary operation. Hey, what do you know? Like, without knowing it, I got 80% of it right just by trying to find some words that I know. Some other ones. In Python, how is memory managed? I have no clue how memory is managed in Python. So ask me.
So how is memory managed in Python?
I don't know, actually, but I know that there's like, Python's a scripting language, and a lot of scripting languages, you're kind of abstracting that kind of stuff off. So I've worked in scripting languages most of my career. I've never really done a lot of manual memory management. If I had to take a guess, I imagine there's some amount of like scalar value kind of storage like you do in JavaScript, and some amount of pointer kinds of things like JavaScript objects. I don't know which things do that in Python and which things don't, but most scripting languages use the idea of reference types and primitive types. So I'm guessing it's kind of a similar sort of thing. There you go. So I asked some question like this in an interview once, and this is so fucking baller. Let's say somebody asks you this and you just don't know. I had somebody ask me once, I don't know, mind if I look it up? And I went, why hasn't everybody just been doing that? And I was like, no problem. Sometimes we get shot down on that, but like that's better than an I don't know. Mind if I look it up? Love it. Fuck yes. Let's say you didn't know the answer to this. Let's see. John, ask me this one.
What is the difference between a tuple and a list in Python?
I don't know. I haven't really worked with data types a lot in Python, but I'm imagining they both have to do with like collections of things. I do know the difference between those, but like use like your ability to infer stuff from context and just hazard a guess. Yeah.
Is it better to guess, or is it better to ask to look it up?
So in like the example of the Python types, like if you have no clue, you could say something like, you could do both. You can say, I imagine that there's strings and booleans, some kind of like key value sort of thing. There is, it's called a dictionary. One or more types of numbers, and shoot, do you mind if I look it up? So now you got the best of both worlds. Cool. What else? You guys know how to do Fermi estimates? I think we did those with you guys like week 2 maybe.
It's like
Mm-hmm. Cool. Let's talk about Fermis. Because you don't get these that much in Denver. This is a super common San Francisco style interview question. So the questions all have the format like, how would you figure out how many, the canonical one is like piano tuners there are in Chicago? Piano.
It's so random.
Another really popular one is like, you're a window washer. How many windows are there in New York City?
There's one with like quarters, right?
I don't know the quarters one.
It's like how many quarters to the height of that really tall building? Empire
Oh
State?
yeah. Stack quarters to Empire State.
That one's pretty easy.
It's the same. It's the exact same kind of problem. One I've used before is like, how many ping pong balls fit in this room?
So this is the kind of thing where it's like, give me the volume of this room and the volume of the ping pong ball, and okay.
So all of these are use the exact same technique, just with different levels of complexity. The piano tuners one is probably the hardest, but it's not any different. So a Fermi estimate, named after Enrico Fermi. Do not do racist impressions during your interviews. So the theorem behind this is that if you make an estimate with ingredients that are all the right order of magnitude, your final result will also be in the right order of magnitude, which is usually close enough. So, let's do the easy one. Empire State Building. So how many floors is the Empire State Building?
Over 100.
Yeah, so let's say about 100. And how high is a floor? What was it?
102.
Cool, beautiful. How high is a floor? 10?
5
feet?
I said 9.
Oh.
I'm not that short.
Okay. You guys, any Being John Malkovich fans?
Yeah.
The 8.5 floor or whatever. Okay, so
14 feet.
cool. So 14. Well, like this is part of it. Even though it's actually 102, even though that's actually 14, if we're in the ballpark, works out just fine. So this ends up being about 1,000 feet. And then about how many quarters would be in a foot?
It's almost an inch diameter. Like,
Oh, stacked like that?
Stack.
I thought it was like
yeah, I don't know.
flat. Okay, so I'm gonna say
That'd be a hell of a way
in
to
an
stack some quarters.
in an inch, I'll bet there's about 6. So like 6 an inch, so 6 times 12.
72.
Thank you. So I'm gonna say 72,000 quarters gets you to the top of the Empire State Building. Let's see what the actual number is. Well, that's how many quarters to top of Empire State Building? So somebody just has it.
240 in a foot?
Oh, not the right order of magnitude. I said 72,000. So 240 quarters. That does not sound right.
They're saying a quarter is about 0.05 inches thick.
Yeah.
So it's not
What?
6
Sounds
quarters.
less right.
0.5 inches.
And that means 240.
There is no way 240 quarters is a foot. That is batshit crazy.
Well, 40 a roll of quarters is about that, and that's 40 quarters.
Here we go.
Yeah.
So
So that's
What,
I would say
240?
like 120 to 160 would be a foot.
And like but you're doing Fermi estimate, you can usually look this stuff up or just ask them how many floors are there and whatever. All right, so that's one of them. Let's do ping pong balls that fit in this room. So what are the dimensions of this room ish? Yeah, I'm going to like 20 by 20 probably. Yeah, it looks about right. 20 by 20 by 15. So that's fuck.
400
Okay, so we're 6,000
Huh?
cubic feet. So at 6,000 cubic feet, now we don't have the entire room available. We got chairs, we have all this ducting, we have all this kind of shit. So you go, about what percentage of this room is like obstructed? 15? 20?
Unless we're counting like that shit too. Yeah.
counting it.
Yeah, so like 15.
to make it easier.
I'd say like
Yeah, close to 10%.
20%.
I'd say 20.
Yeah.
I'm going to go with
10%. Yeah,
10.
You put them underneath the desk and like around the desk.
Cool, so that brings the actual available square footage down to 5,400 square feet. So ping pong ball, what are dimensions on a ping pong ball? About an inch. So then we say, how many of those then fit in a square foot? Oop, both directions.
244. Wait, 12 to 12 is 144.
In a square. You said
Yeah.
square.
So,
They'll stack slightly
so 144 in a cubic foot. So if we have that many, what's the calculation?
144.
5,400 divided by 144.
Times.
Sorry, yeah.
So this times this. That's about how many ping pong balls would fit in this room. Ta-da!
Fit more than 144 in square foot because they're not cubes,
They're not cubes.
so they'd stack better. There'd be less negative space.
No, they wouldn't.
I don't think, no.
Because they can't take up any more than a square.
Yeah.
Cube.
They can.
They'll go like this way. If you put them in a square room, they'll
That is
stack as squares.
They won't. They will shift down. They won't.
But if you wanted to make, okay, so if you wanted to make that argument, they nest kinda, then just add that as a factor in here. So I go, I'll bet I can get about 15% more ping pong balls because they sort of nest inside of each other. Cool. So the hard one, piano tuners in Chicago. What are some factors that you would use to figure this one out?
Population of Chicago.
Population of Chicago.
Wait, but that one, you just get a white pages and look up how many piano tuners there are in Chicago. Like, that's the thing about logic puzzles sometimes that I'm just like, that's not logical.
My wife also hates these for the same reason. It'll be like, if you close your eyes and open your sock drawer, what is the percentage chance you'll get a red sock? So turn on the fucking light.
And also, you know where your red socks are in your own
There you go.
drawer.
All right, but you get asked this in an interview. Population of Chicago is a factor. What else?
Percentage of piano players.
Okay.
Population.
So percent of piano players. What else?
I would
Actually,
think
maybe even
piano
just pianos
owners.
owned. Yeah.
Okay, so like ownership rate. Okay, what else would you consider?
How many tuners per, or
I think it would be like how often a piano needs to be tuned.
There we go. How often are pianos tuned?
And then how many pianos can a tuner tune in one day?
How many can someone tune?
Wouldn't you also need to know how long people have had their pianos, so if they are being tuned?
Oh, yeah, so like I own one, maybe I don't play it all that much. That kind of gets accounted for in how often our piano's tuned. So all this stuff together, you can make a pretty damn good estimate. So I did this with 3 or 4 different cohorts. All of them got within, well, this is the other cool thing about it. I had them like in pairs figure it out, and then we averaged everybody's numbers together. And every single time we've done that, we've been within like a dozen of the actual number.
Does this account for like public pianos and pianos that are owned by businesses and stuff?
So Chris fucking Taro from Get.Money, Jesse's cohort, he's like a piano guy. And so like as we were working through this problem, he's like, that's bullshit. I know the University of Chicago, they got a minimum 200 pianos. But like you can add those in, like whatever data you got, like work with it. But Fermi estimates in general are super resilient to little stuff like that.
It's my favorite thing. All of operations is all about making Fermi.
There we go.
All the time.
Other questions?
If you ever like freeze up for a question,
Uh-huh.
and you ask like, so like, where would you recommend like starting, or like, what do you do? Like, I know you kind of already got this with the impossible question, but like, I don't know. I can just see myself getting asked a question, and being like, God, I know I can figure it out, but I just don't even know where to start with it or something.
Okay. So,
Like for the piano players in Chicago, because like I was like, I don't even know what kind of data you need to solve that.
okay. So, first thing you want to do is buy yourself some time. So, you go, let's say like I'm like freezing up. My brain is just locked. I can't even figure out where to start. Mez, ask me the piano tuners question.
Can you tell me how many piano tuners there are in Chicago?
How many piano tuners are there in Chicago? City of Chicago, pianos. How many people are there that can tune them? I'm a piano tuner. How many people am I competing with in the city of Chicago? And here's the thing. So not only do you buy yourself time when you do that, if you rephrase the question a bunch of different ways, sometimes you see the angle on it.
But is it never okay to ask for a starting point? What if you're completely stumped and you don't want to stand there for
That's
10
better.
minutes?
That's better than going, oh no.
Well, right. You don't want to stand there for 10 minutes being like,
Mhm.
how many?
Sure.
Like, yeah, balance to this, where you're finally like,
Sure.
what's like a nice way of asking for a hint? Anything versus I don't know.
So if you're gonna do something like that, I would try to like inject some humor in it. As like, mind if I phone a friend? Will you be my friend? So like, I'd prefer that to nothing, but like last resort. Yeah.
Can you say something like, I'm not sure where to start, so I'm going to break this down into smaller
Yeah.
chunks, and then just start like just breaking the question down rather than.
Totally fair.
And can you say like, can you let me know if I'm on the right track?
That's fair. A lot of times they'll just let you know. They'll go, you are barking up the wrong tree. Okay, so true story. I'm interviewing for lead instructors for this school, for the job that would eventually, thank God, go to Damon. And I about a dozen different computer science PhDs, and there's a standard interview that we do for instructors here. It's a debugging interview. And without fail, every single one of those folks would go in the exact wrong direction. They'd go like, well, can you show me the definition of this function? I go, don't worry about it. That function is not the problem. Like, I think it is. What? No, I just told you it's not. And like I had multiple people just try to bulldoze through me on that. You're like, I know, no, I have a hunch it really is somewhere in here. I just told you, man. I'm just trying to throw you a bone. And none of them could program, none of them could teach. It's baffling. But yeah, like breaking it down to a smaller problem, totally fair. Am I on the right track? Totally fair question to ask. They might just say, I don't know. I'm not giving any hints. All right, but you don't get subtracted points for asking.
Don't you though?
No. You get subtracted points, things that will like ding you in an interview. Also, not solving the problem, honestly, not as big a deal as you might think. Things that will like cause you to fail a whiteboarding interview are not trying, going dark. Those two things are like, that's 0 points. And like, don't discount how many points you can get for being like pleasant to be around. If you're a dick in the whiteboarding interview, it's like, cool, I think we can skip the culture screen. But I wasn't prepared to be charming. Because like the entire time you're doing this, they're imagining like, all right, I'm working through a problem with you. What's this gonna be like? And if you're asking me questions and I don't know the answer, that's one thing. If you're like, I kind of feel like you should give me a hint. That's like, well, fuck, man. Is that what it's going to be like to supervise you? Or like you just work silently on your own, or you don't, all right, cool, you don't know anything. Will you try something? You just throw a Hail Mary? Like, and it kind of depends on the culture of the shop, but that's one of the things that they imagine they are ascertaining out of these interviews. Yeah, not getting the interview, or not getting the question right, not that big of a problem, especially if, like, for example, you don't know what a Fibonacci sequence is, or you've never written a recursive function before or something. If you're willing to give it a shot, that goes a long way. And if your thought process is clean, if you're approaching it like a sane programmer, you get a lot of points for that. And can you say what's on your mind like in an eloquent way? Yeah.
I have a question about bias and like subjectiveness.
Mm-hmm. Oh yeah.
Because like in a perfect world, yes, you would be graded on whether or not you can speak and whether or not you solve something or have like at least a thought process and stuff. Some of us, there's like other barriers.
Sure.
So how, like, is there just a way to tell, or is there a way to, like, I don't know, like, I don't really know what my question
Sure.
is, but it's more like, how do you ameliorate those things in your own interview?
So I'll go back to something I said earlier in this, which is basically no competent interviewer is asking you any of these things. So that's like warning sign number one. And so like, just like buckle up. If you're getting answered a bunch of these interview questions, that's also communicating something to you about that culture. But there are like semi-valid ways to do this kind of thing. Like my preferred way would be something like, I'm going to give you like a list of potential questions you're going to be asked ahead of time so you can practice these. I don't want to see you at your worst. I want to see you think out loud. I want to see your process to solving something like this. I've also just given people the answer before. I was like, here's the problem. Here's the answer, by the way. I want to see you get to this answer. But you're probably not going to get those. So some of it just sucks. And when you're in a position to hire people, do better. But other things that will play to your advantage if you are a otherwise underrepresented group, is always talk the entire time. Because it's as soon as you stop talking that people start filling in blanks about who you are and what you know and that kind of shit. So if I give you one, like, do not forget this, just talk the entire time. And the only way that you'll get good at that is practicing. Like, me saying that to you is not going to do it. It's why we do the whiteboarding Wednesday thing. It's a party trick, and that's what it is. Also, okay to make a mistake. I think I did it at some point when I was doing this thing. I just started barking down the wrong tree. I had like an else if that I didn't need to have, something like that. Completely fine. You could even like approach the entire problem wrong. You just need to start over again. That's not a problem if you're talking while you're doing it. You go, oh, you know what I'm actually just realizing? That would never be the case because the entire range of inputs, we don't even need that condition there. All right, so what I'm going to do, I'm going to start this over again. Totally fair game. What else? What else do you want to know about this type of interviewing? Cool, go and suck less.